Hello friends, welcome to our channel. In this lecture, I would like to explain another example, that is example 4, based on the topic moment distribution method. Already in the last 3 examples, I explained very clearly based on the continuous beams. But here today I will going to discuss about the portal frame by using moment distribution method. So before going to solve any type of frame, first you have to make it confirm whether it will comes under the sway analysis or non-sway analysis. So all of you people know what are the conditions for the sway analysis. So already by solving in the Canis method, by using the Canis method, I explained very clearly what are the conditions for the sway analysis. But today also I will show what are the conditions of the sway analysis. See here, our first condition for this sway analysis is unsymmetrical loading. Unsymmetrical loading. Then unequal heights of columns. Unequal heights of the columns. Different moment of inertia of the columns. Then unsymmetrical, different end conditions. Different end conditions. So these are the conditions for the sway analysis. So for sway, if any of this condition happens in the frame, then the column leads to the sway analysis. So observe here clearly in the frame, unsymmetrical loading. But here in the frame, there will be symmetrical loading on a beam or BC. So that is 100 kilonewton meter. So if you check exactly, half of the frame consists of 50 kilonewton, like that it will be distributed equally. So here there will be symmetrical loading. At the same time, for the what is the condition of the second condition for the sway analysis, unequal heights of the column. If you observe whether here the column will be some 4 meters by 3 meters, like that. For example, AB will be 3 meters and CD will be some 2 meters or some 4 meters, which is less or more than 3 meters. At that time, there will be difference in the heights of the columns. So then the column leads to the sway analysis. But here in this problem, the column heights are also equal. Then different moment of inertia for the columns means, so take down, sorry, here different moment of inertia for the columns. See here different moment of inertia for the columns. Here column property, for AB it will be I and for CD it will be I only. For example, in some cases AB will be equal to some 2I and CD will be equal to some I, then there will be difference in the properties of the column. At that time also the column leads to the sway analysis. At the same time, different end condition, at end A it is fixed and the end D also it is fixed here, but sometimes end A and D are, one end will be fixed. For example, end D is simply supported means, then at that time the column leads to sway analysis. Otherwise, if both ends are hinged also, no problem. If both ends are hinged are also fixed are also, no problem. But one end will be fixed, another end will be simply supported. At that time also the column leads to the sway analysis. Out of these 4 condition, any one condition happens in the frame, then the column definitely leads to the sway analysis. If you observe in this frame, both column heights are equal, same property of inertia for the columns, then both ends are fixed, at the same time symmetrical loading. So all conditions are symmetric manner only, that is the reason the column comes under the non-sway analysis. So out of these 4 condition, any one of the condition satisfied, then definitely we can go the type of frame for the sway analysis. But here all the conditions are satisfied for the non-sway analysis. So then we will go for non-sway analysis. You please remember one note point here. What if you go for the moment distribution method? So already we solved so many problems based on the continuous beams. So non-sway analysis is also like continuous beams only. So here it will be in the format of the frame ABCD. So in what way we have to take down the tree diagram? So you please observe that one. Just like as the continuous beams only, we can take down in the format of the continuous beams. See A, B, C, D. So there is no loads for A, B and C, D. So in the same way, in what way we are considering for continuous beams, in the same way we are taking the moment distribution diagram for the frames also. For example, if any load is happens, means take down fixed moments directly here. So entire procedure also same as the continuous beams, but I will explain briefly here. So what about the fixed moments? Our first point is to solve the fixed moments. See here, M bar AB and M bar B. There is no loading conditions for AB and BA. Therefore, M bar AB will be equal to 0, M bar BA will be equal to 0. So fixed moment for AB and BA will be equal to 0. Similarly, M bar CD and DC. So there will be no loading conditions for M bar CD and DC. Therefore, for both CD and DC, it will be 0. Here there will be no loading conditions and here there will be no loading conditions. Then what about fixed moment for BC? For fixed moment for BC will be equal to whenever an UDL is acting on a span, then the fixed moment for BC will be equal to minus WL square by 12 and fixed moment for CB will be equal to plus WL square by 12. So what about W here? W will be this given load, that is 100, and L is the length of the particular span, which is 6 meters, divided by 12. If you simplify, you will get directly minus 300 kilonewton meter and plus 300 kilonewton meter. So these are the fixed moments. Sometimes there is a chances of asking point load or UDL on the column also. Take down the fixed moments also. For example, if a point load is acting exactly at the center, minus WL by 8 to plus WL by 8. If any symmetrical loads are eccentric loads are happen on both the columns, that type of columns are also comes under the non-sway analysis only. So if any loading condition is given, take down fixed moments based on that loading conditions. Then go to the next step, which is distribution factor. See here, distribution factor. So before going to calculate the distribution factor, so always remember these two steps. If the far end is fixed condition, our relative stiffness K value will be equal to I by L. If the far end is simply supported condition, our relative stiffness will be equal to 3 by 4 times of I by L. See here, so A and D are the end supports, B and C are the intermediate supports. Therefore, I am taking joint will be B and C. Similarly, what are the members here? For B, connecting members will be BA and BC. Similarly, for C, connecting members will be CB and CD. Therefore, I am taking as usually for joint B, member BA, BC, CB and CD. So both ends are fixed condition. So therefore, I am at the B and I am looking A. So A is the far end which is fixed. Therefore, I am taking directly here I by L. Similarly, BC. C is the intermediate joint. So always intermediate joints will be considered as the fixed supports. So already I explained that concept in the continuous beams itself. So that is the reason. If you see that video, if you watch that video means, then you will get a clear concept based on the moment distribution method. So that is the, even though the problem will be on the non-sway analysis, entire procedure will be same as the continuous beams only. So if the far end is fixed for BA, I by L only. Similarly for BC also, far end is fixed, you will get I by L. But here observe for BA, I value will be equal to I. Similarly for BC, I value will be equal to 4I, which is given in the question itself. Then L value will be 3 meters for BA. Similarly 6 meters for BC. Then if you simplify, you will get I by 3 and this one will be 2I by 3. Again, what about the relative sum of the relative stiffness? Sum of the relative stiffness means you have to add these two, BA plus BC, means I by 3 plus 2I by 3. Then directly you will get, if you simplify this one, you will get I. Then go for relative stiffness for CB and CD. So I am at the C position, I am looking B. B is the intermediate support which is considered as a fixed one. Therefore, that one will be I by L, where I value will be equal to 4I and L value will be equal to 6 here. Simplify that one, directly you will get 2I by 3. Similarly for CD. For CD also it will be D is the far end which is fixed here. Therefore I by L only here, where I equal to I for the particular column and L is the length of the particular column which is 3 meters here. Then after that, total relative stiffness. So add these two values, CB plus CD. Then you will get directly this value I. Then distribution factor. Already you people know the formula K by sigma K. So while talking about the BA distribution factor, take down K value this one and sigma K value this one. So some of the moments, some of the distribution factor, relative stiffness at that particular joint means I by 3 divided by I. So if you simplify that one, you will get 1 by 3. Similarly, 2I by 3 divided by I for BC. Then you will get directly 2 by 3. Similarly for CB, 2I by 3 divided by I. You will get 2 by 3. Similarly for CD distribution factor, I by 3 divided by I. Then you will get 1 by 3. So what is the procedure for solving this distribution factor? K by sigma K. While talking about CD distribution factor, K value will be this I by 3 and sigma K value will be this one. Directly you will get a 1 by 3 value. Then go to the next step, which is moment distribution table. So this is the moment distribution table. See here A, B, C, D. So if you observe clearly this diagram, if you observe clearly, A will be fixed here, A and D are fixed here. Similarly, B and C. So even though it will be a frame, we are drawing like a continuous beam. So that is the procedure we have to remember in this moment distribution method. While solving the problem based on the Canis method, as it is, we can draw the same T diagram, same frame diagram based on the Canis method in the format of frames only. Already I shown the type of models also in our channel and uploaded in our channel playlist. So if you go and watch that one, you will get a clear idea what is the difference between moment distribution method procedure and Canis method procedure. So you remember one thing, even though we are drawing, we are taking moment distribution table, so we are taking same like as the continuous beams for frames also. Then so joint A, B, C, D are the joints and members for AB will be taken here. Similarly for BA, BC, CB, CD and DC. Okay. Distribution factors, what we are calculated in the last step. So 1 by 3 for BA, 2 by 3 for BC. Similarly, CB 2 by 3, CD 1 by 3. Say as usually I am taking here 1 by 3, 2 by 3, 2 by 3, 1 by 3. Then fixed moments. So already we calculated that one also. For ABA and CD it will be 0. Similarly for BC and CB it will be minus 300 to plus 300. So whatever the fixed moments we are calculated in the previous step, we are taking same fixed moments. For AB it will be 0, for BA it will be 0, for BC it will be minus 300, for CB it will be plus 300. Similarly for CD it will be 0 and DC it will be 0. So already people know how to balance this moment distributions table. So our next step is to balance that one. So here one more point we have to remember. If it will be a simply supported, if there will be any simply supported end or any overhanging positions will be there. So at that time for overhanging positions we have to balance that position. Okay, for simply supported end will be there means we have to before itself we have to make that one 0 and then we have to carry that moment to the other end. But both ends of the frame will be fixed here. So you can go for balance directly. Why? Because you will get moments at the fixed ends also. For example, if end D is simply supported or end A also simply supported, so whatever the fixed moments there, so you can make the fixed moments 0 by taking the same value with opposite sign. Then we can carry the whatever the moment we are taking for balancing, we are carrying the half of the moment to the other end. So that is the procedure happens if both ends are simply supported. But here both ends are fixed. At the fixed end you will get some moment. That is the reason we are going general procedure only. Here it will be 0. At the joint we are going for balancing. See here whatever the moments we are taking some of the joints, moments at a particular joints means 0 minus 300 into its distribution factor. If I want distribution factor for BA, I am taking 0 minus 300 into 1 by 3. I am taking here directly. Why? Because already I shown 3 models based on the continuous beams step by step procedure. So here I am taking directly. I am calculating directly calculated itself. See here I am balancing here. 0 minus 300 you will get minus 300. So minus 300 into, if I want distribution factor for BA means I am taking into 1 divided by 3. So how much you will get? You will get 0.33. So what is the procedure here? (300) into divided by 3. So directly simplify that one, you will get 100 only. 300 divided by 3 will be equal to 100. So here there will be minus symbol. So while taking in the balancing step, so you always take opposite value. So for example, you will get minus 100. So that is the reason I am taking plus 100. That is the procedure for balancing here. Similarly, see here 300 minus 300 plus 0 into 2 by 3. 3 into 2, 600 divided by 3. So you will get 200. So if you simplify directly, 3 into 2 minus 300 into 2 by 3. 600 divided by 3, directly you will get 200. So for example, here you will get minus 200 means I am taking plus 200. In the same way, you have to balance here plus 300 plus 0. If I want distribution factor for CB means I am taking this one directly into 2 by 3 means 300 into 2 by 3. So the same value will get plus 200. So here I am taking minus 200. Similarly, here plus 300 into plus 300 plus 0 into 1 by 3. You will get 300 by 3 equal to 100. So here you will get the value in terms of positive. So I am taking here negative. Then after completion of this step, immediately you can go for carry over step. So already I told you so many times, balancing takes place at these joints, carry over within the span. See here there will be 100 kilonewtons. So I am carrying exactly half of the moments to its other end, means plus 100 by 2, which is 50 here, that is plus only. So carry over takes place with same side. Similarly, here actually from here to here also it will be carry over, but there will be no moment here. Then here this value, here carry over takes place within this span like this. Again this movement will be carried to its other end. Again this moments will be carried to its this end. Similarly this movement will be carried to this end. For example, if there will be any movement, that movement will be carried to here. But here there will be no movement, that is the reason I am not carrying any movement to this side. So carry over takes place within the span. For example, remember for AB to BA, BA to AB. Similarly, in the BC span, BC to CB, CB to BC. But balancing takes place at the joint, means some of the moments at a particular joint into its distribution factor. Okay. See here you will get minus 100 means half of the moment, that is minus 200 divided by 2. You will get minus 100. Similarly, this value plus 200 divided by 2, you will get 100. Again I am distributing this moment to here, which is minus 50, which is 100 by 2. Again go for the next trial. So this is up to, you consider that as first trial. Again we are going for second trial, that is I am going for balancing here. So already you people know what is the procedure for balancing. Again I am taking balancing for this moment. Minus 100 there is no value, means 0. Minus 100 plus 0 into 1 by 3. So directly take down 100 divided by 3. So how much you will get? 100 divided by 3. So you will get 33.33. I am taking directly. So here in terms of negative, therefore I am taking positive 33.33. Similarly, in the same way, here minus 100 into 2 by 3. Minus 100 plus 0 into 2 by 3 means 100 into 2 by 3 means 200 divided by 3. So you will get 66.66. Here the value in terms of negative, therefore I am taking positive symbol, means just I am changing the sign of the value, minus 66.67, sorry, plus. Again I am going for the balancing for the next step, which is 100 plus 0 into 2 by 3. Same way you will get 66.67 here, but here there will be positive sign, you will get negative value in the balancing step. Similarly 100 plus 0 into 1 by 3, the same value you will get, which is minus 33.33. Here you will get positive value. I am changing the sign of that value and taking here. Then go for the next step, which is carry over. See here, carry over always, I told you, carry over takes place from BA to AB. So 33.33 divided by 2. 33.33 divided by 2. So that is 16.665. I am after digit 2 decimals, which is 16.66. So the carryover takes place from BA to AB here. Similarly 66.67 divided by 2. 66.67 divided by 2. So that one will be 33.33. 33.33. But here carryover takes place from CB to BC. So you will get a negative 66.67 divided by 2. Here the carryover takes place from here to here, which is BC to CB. So that is 33.33. So the value from BC to CB. Again the carryover takes place from CD to DC. That is minus 33.33 divided by 2. Already the same value will get here, which is minus 16.66. So I will assign the symbols also where it will take place carry over. From here to here, similarly from here to here, similarly from here to here, similarly for here to here. Again we can go for balancing and carry over. Again we can go for balancing and carry over. Like that we have to repeat so many trials. So up to how many trials we can go? See here. If you observe this one very clearly, so already I shown here 2 steps. See here, if you observe this one, so there will be so many trials. So this is first trial. Similarly, this is for second trial. So for second trial, up to you will get here. So like that, how many trials we have to repeat? See here, there will be so many trials. For example, this one will be third trial. Similarly, this one will be fourth trial, and this one will be fifth trial, sixth trial, seventh trial. Again, eighth trial, ninth trial. So like that, you can apply same procedure for balancing and carry over. So in what way you have to balance? You can take some of the moments at a particular joint. For example, at B, you have to add these two moments, and then whatever the distribution factor you want, you can multiply with that moment. For example, 0 minus 300, if I want distribution factor for BA means into 1 by 3. Again, if I want distribution factor for BC means into 2 by 3. 0 minus 300 into 2 by 3. Like that, you will repeat the same trials. Up to how many cycles we have to do this procedure? If you observe very clearly, each and every step, for example, here the moment will be 16.33.33. So in the next trial, it will be decreased to 11.1111. Like that, if you go on repeat the cycles, you will get 0.41. Again, you can go on repeating means finally you will get 0.02. So like that, after digit at least 1 0, you can opt this type of trials. at least 1 0. For example, you can repeat this procedure means again you can go for next cycle means again for balancing and carry over in the next step there is a chance of getting 0.015, 0.001, like that 0.0. After 0 digit there will be 2 decimals 0 means approximate that value will be equal to 0 only. So like that you can go for approximate values up to some 0.001 or else 0.002, like that after digit at least minimum 1 0. So if possible you can repeat that much of cycles, then you will get a correct value. So then you can add all these values in the AB, BA, BC. See here, after that I am adding all these values: 50 plus 16.67, 5.56 plus 1.85, 0.62. So you can add all these values, you will get plus 75. Similarly you can add all these moments for BA, then you will get a plus 150. Similarly you can add all these value means you will get minus 150. So again for BC and CB and CD also you will get a plus 150 and minus 150, and here last value which is DC value will be equal to minus 755. At the same time at the moments, some of the moments at a particular joint will be equal to 0. So for BA it will be plus 150, similarly for BC it will be minus 150. If you add these two you will get a 0 at that particular joint. So sum of the moments at a particular joint will be equal to 0. So you remember that point also. So this is the actually each and every procedure will be same like as the previous one only. So if you solve one problem accurately means remaining problems are also same. You just know the difference, what are the procedure we are opting for the continuous beams and what are the procedures we are opting for the non-sway analysis in the frames. Entire remaining procedures will be same. Thank you so much for watching this video. If you really like this video, please like this video, share it to your friends and subscribe our channel. Thank you so much.